You probably remember the images from 2011, a massive earthquake off the coast of Japan that triggered an absolutely devastating tsunami. But, hidden inside that tragedy is a really fascinating scientific puzzle. It's a mystery about time, and it starts the very second the ground started to shake.
Okay, so look. The city of Sendai was incredibly close to the earthquake's epicenter. So logically, you'd think the first wave would have hit almost right away, within just a few minutes. But it didn't. Instead, the city had this 30-minute window. Understanding why that delay happened is actually the key to saving lives in the future.
30 minutes. Now, this isn't just some random number. It's the central clue in our whole investigation. In the world of tsunamis, where literally every single second counts, 30 minutes is basically an eternity. It's so much longer than expected that it kind of turns what we think we know about these waves completely on its head. So what on earth was happening during that half hour?
To solve this mystery, we have to start at the beginning, right? We've got to find the tsunami's origin point. And just like in any good detective story, the most obvious clue, well, it's often the one that leads you down the wrong path. I mean, this makes total sense, doesn't it? You have a gigantic earthquake just off the coast, so the massive wave it creates must have started right there. That's our prime suspect. It's the simplest explanation, and it's what most of us would probably assume is true. And here's where that simple theory just completely falls apart. See, if the tsunami really did start at that nearby epicenter, there is just no way, physically, to explain a 30-minute travel time. The wave would have been there in minutes, period. The facts just don't line up. So the most important takeaway here is this. Our prime suspect is innocent. The tsunami did not start where we thought it did. So that means we need a whole new theory and a new culprit. The true source, the real maker of this tsunami, was actually hiding somewhere else entirely.
So what was it? Well, it wasn't the earthquake's epicenter. It was the violent, sudden movement of huge underwater mountains, much, much farther out at sea. That's what displays the enormous amount of water you need to create a wave that big. Think of it like this. The earthquake was the trigger, but these mountains, they were the factory.
Calling these mountains the manufacturer of the tsunami is such a powerful way to think about it. An earthquake can happen near the coast, sure, but it can't on its own create a tsunami from land. All the action, the real wave-making, has to happen way out in the deep ocean, where these giant landforms get physically moved around.
Okay, so we've found our true source, these distant underwater mountains. But that only solves, half the mystery. It tells us where the wave came from, but it doesn't explain why there was such a long delay. To get that, we need to dive into the secret physics of how a tsunami actually travels.
The second those underwater mountains move, they actually create not one, but two different kinds of waves. The first one is called a pressure wave. The best way to think of this is like the flash of lightning in a storm. It's this invisible shock wave that just rips through the water at an incredible speed. It's pretty much instantaneous.
And then there's the second type, the one we all recognize, the surface wave. This is that visible, destructive wall of water. And just like the roll of thunder that comes after the lightning, this wave travels much, much more slowly. It's a huge mass of water that has to physically make its way across the ocean's surface. So what we have is the lightning-fast, invisible pressure wave and the much slower, visible surface wave. And depending on how far it has to go, that surface wave can take hours to finally reach the shore. This massive difference in speed, well, that's everything. That's the whole key. So let's walk through how it all fits together. First, a mountain moves way out in the sea. Instantly, that pressure wave shoots out in all directions. At the very same moment, the surface wave, the actual tsunami, starts its long, slow journey. And it's that journey, from that distant starting point all the way to the coast, that takes time.
So now we have all the pieces of the puzzle. We have the real culprit, and we have the secret mechanism. Let's put them all together and officially close the case on the 30-minute mystery.
All right, let's ask our main question one last time. We know the earthquake was close, but we know the wave was slow. How is that even possible?
And here is the answer, plain and simple. The tsunami wasn't born right next to the coast. It was born way out in the middle of the sea. It was manufactured by those shifting underwater mountains. And crucially, the visible surface wave, the one that causes all the destruction, took exactly 30 minutes to travel from that distant starting line all the way to the coast of Sendai.
So the amazing thing is, this wasn't some kind of freak accident or a weird mystery at all. It was just predictable physics. That 30-minute delay was simply the travel time.
It's a pretty stunning reminder that what seems like a crazy paradox often has a clear, scientific, and logical explanation, if you just know where to look.
And this whole thing brings us to a final thought. We just unraveled a mystery that was hiding in plain sight right in the middle of a global catastrophe. It really makes you wonder, doesn't it? How many other things that we just take for granted, things that seem totally obvious, are actually complex and fascinating puzzles, just waiting for us to ask the right questions? What do we dig into next?